want to introduce you to the third and last speaker today, Jonathan Pichot. So Jonathan is a technologist and an urbanist, focusing on how technologies can use technology in ways that address challenges in the built environment. And Jonathan is also one of 3 Malmö residents. So currently there is 50 organizations in the city that is hosting 3 people from across Europe as residents in Malmö that are here to do some work. And Jonathan is one of them. And it's fantastic that you're both a resident and was a perfect match for this seminar. So yeah, we're looking forward to hear your work on how to make sensors, etc., transparent and readable for people. So please give a warm hand to Jonathan Pichot.
Thank you. And thanks, Martin and Media Evolution. Is this good? Too loud? For the invitation. And I think the curation is really impressive. I will be talking about open source. I will be talking about sensors and technology in public space, making it accessible, understandable. I think it's a very good line. So very quickly about me. I like to call myself a passionate urbanist, and what I mean by that is someone who cares about communities, cares about the built environment, cares about the way these systems work, how we feel in spaces, and also a skeptical technologist. I make my money as a full stack developer for a lot of my career. I know how technology works, but I'm also often skeptical about it being the primary mental model for solving problems and for the way in which it has influence in our society. And we're going to talk about work I do for an organization called Helpful Places. I'm currently independent, but I work with them about half-time. And they work on what we're going to talk about, which is the built environment. I'm going to start with, I think, something that probably was pretty easy to convince you about, and especially after Violet's conversation as well, that data collecting technology, and I'm calling it data collecting instead of just digital technology, is deeply embedded into our built environment. It has been for quite a while. It is only increasing, and so much so that it really is invisible. I think the classic example is the CCTV camera. It's been around for a while. It's so common we forget it's there. It's nearly everywhere. We have more advanced technologies that are coming in, sometimes explicit in our face. This is a facial recognition tool to just check in at an airport. You might see this at a gate when you're crossing a passport control. But of course, these technologies also are hidden. Sometimes we go into shops or other places. We don't really know how many times our face has been taken. Now, a thing I like to think about when I walk by a really common, let's say, tourist area, the Eiffel Tower, how many images I'm in other people's books, right? Like, you know, if you look at your images from your trip somewhere, there's somebody in the background. How many times have I been in the background? How many times has a camera been around me and captured me? And how many times has that data been used for something? We also have really a lot of banal data collecting technologies in space. This is just a traffic sensor. We have a lot of things that are collecting data about the way we might have moved around that isn't necessarily personally identifiable, but still data collection in this space. And of course, this is causing a lot of conversations. This is an article that was published a few years ago about just the growing number of Bluetooth beacons that exist in space that are tracking on our phones and even allowing the SDKs in our phones to access that information. So I walk into a store, I have the app of that store, I get a little notification that there's a deal going on, that kind of thing. And this data is really collected, again, essentially universally in airports and museums and all sorts of other public spaces, often unaware. In the country I live in France, in Paris, we are going to be hosting the Olympics soon and recently passed a law that goes against European law to bring in more AI surveillance during the Olympics. So this will be cameras that will track people's sentiment, see if people are suspicious, see if they're track maybe a bag that was left over. So these are debates that we are having. I think probably would convince most of you. And so it's often unclear why these technologies are here, who is responsible, who is on the other end listening into that data flow. We have laws that require some sort of notification. They are really sort of, they exist. We have these kinds of signs, but they are often inconsistent. There's really no clear rules around the way they're supposed to look in the kind of communication that they might be trying to produce. They are unclear. There was rarely any kind of design research that was done around how these signs should look and should be able to express to a diverse group of people the same piece of information. And they're unreliable, because often they are, in a deployment of technology in public space, sort of the afterthought. They're like, okay, we got to paste that image in public space, we're going to do that. But there isn't necessarily the internal capacity to make sure, like the one in Hackney, that there aren't stickers on it, that we maintain that this piece of information, this display, is clear over time. Now we have a tool that we use, that even some of that image of Hackney tries to use, which is visual languages. We use visual languages to explain concepts and make them more accessible. And there's a lot of examples that I'm sure you have seen. This is a very typical example. This is the international symbol of access. It's essentially globally known of what this might mean. We have others that warn us of things. This is the ISO standard for toxic material. And also regionally. This is the European Organic Food Label. So, what are the organization I work for, what are we working on? We are working on an open source visual language called Digital Trust for Places and Routines, we call it DTPR, that aims to increase the transparency, legibility, or as Martin said, readability, and accountability of data collecting technologies in the built environment. Okay, that was a lot. But that's the goal of this visual language that we've been working on. It emerged in 2019, also a little connection to Violet, during the Sidewalk Toronto project. So Sidewalk Labs was Google's big urban tech initiative. They won an RFP in Toronto to develop a part of the waterfront. And in that project that you should look into, it had a lot of interesting results, one of which was the realization of a need of some sort of visual language to describe these technologies that exist in public space. And so through a whole bunch of public charrettes and design sessions, this first version of this open source from the beginning standard emerged. And what is it? First, it's a taxonomy. So taxonomy, the science of classification, it takes the way that maybe a bird watcher might go identify a bird and say, okay, what are the major characteristics of this bird so that I can really describe it? You do the same with a sensor. You pick a sensor and you say, what is its purpose? What technologies are being used? How is this data being processed that's produced by the sensor? What kinds of data? Who has access? How long? And where is it stored? So to give you a few examples, we have, for example, the first thing we ask, who's accountable? Oftentimes, it's the logo of an organization. We have different elements in the taxonomy to talk about purpose. So we say, okay, maybe the purpose of this sensor is planning and design, or commerce, like those Bluetooth beacons we talked about, or safety and security, like CCTV cameras. We also include a description that is meant to be common across all of these different elements in the taxonomy. We also work on translating them. This is a big challenge if we think about trying to build a global standard, which is how do you express the words that make sense in different languages, as well as images that might make sense in different cultural contexts. And so this taxonomy is pretty big. If this should work. Oh. Well, what you would see is a scrolling list of how big this taxonomy is. There's a lot of elements, and it's a living standard. It's meant to adapt itself as new technologies arrive, as new affordances are available, as new ways in which we use technology also are deployed. And in this taxonomy is a design system. So we use the hexagons to represent who's accountable, the purpose of this technology, and the technology itself. We use circles to describe the data type and how it's being processed, and then a square to say sort of retention, how long is it being stored, where is it being stored, etc. And we put them together in a signage guideline. And this comes from the user research, which tries to answer the 4 primary questions that people asked when they encounter technology in public space, which was, what is the purpose? Who can put this here? Who's responsible? Can I be seen? So essentially, what is it doing and with this data? And how do I learn more? How do I ask questions? How do I engage with this piece of technology? So we took those 4 questions, and those 4 questions tend to align with a lot of the requirements in any kind of already regulatory privacy requirements. And we put them in these hexagons that are meant to quickly, sort of visually, if you imagine as fast as you understand when you see this, sign there that tells me that there's something that can help someone with a heart attack, that I could say, okay, right now, this is what this technology is doing, this is who is responsible, etc. And so this is what it looks like. This is a project we did at Sydney Olympic Park during the Women's World Cup that happened earlier this year. We have a major signage that sort of explains the project. We also have signs that talk about a specific piece of technology. And right now we're using QR codes as the way in which people can give feedback. We'll talk about that a little bit more, but that's sort of how it comes together in the built environment. We also did a project, this is in Angers in France, same thing, signage that explains to you the general project, individual signs on individual pieces of technology. And the way it works, you go up, you're able to scan the QR code, and you end up on this little guide app, we call it, that explains to you, for example, the purpose, a little bit more of text, and then gives you what we call the data chain, which is essentially the story. As we've used these elements, we've put these elements together of the taxonomy, and now you have the story of what this sensor is doing. You're able to dig in deep, and really the negotiation here in terms of design is how can it be easy enough, or it can distill itself into those 3 icons to be very quickly recognizable, but also technical enough for someone who knows what they're talking about to dig in and realize no one's hiding anything from me. Because there's going to be a skepticism, as always, in these kinds of deployments of these technologies. So yeah, just extract that for you a little bit more. This is what this data chain looks like. This is how the sort of output of using this taxonomy to describe a piece of technology. We've deployed it now sort of really around the world, usually with municipalities who are interested in working on these kinds of questions. We've also worked with organizations that tend to be test beds, where they say, okay, we're going to build this new neighborhood, we're going to want to test different technologies. And what we're interested in is how this common visual language makes it very clear for citizens or for the residents to understand that this new thing that now just was installed is part of the same project, and have an immediate understanding of where they can get more information, where they can engage, instead of pieces of technology sort of popping up without a very clear understanding of why or who's involved. And in all of these deployments that we've done in these cities, we found that DTPR, in the user research we've done, does promote public trust. I think a good example I use, or metaphor, is an emergency phone number. You don't use it every day, but you're really happy it's there. You're happy it exists. And I think that's often the case with this kind of public trust layer. You're not going to be going to this website every day, but you appreciate that there was the effort for setting this up, and you know exactly where to go if ever you do have a question. It also creates a shared language. And this is really important. I think it creates a shared language amongst the public sector, the media, the citizens, even amongst or within a local government, to talk about the technology, to reason about the pros and cons. Because a large part of this is that different communities, different societies, different democracies are going to take different choices in terms of how much data to give for other kinds of services. I think that's appropriate. But the problem right now is that there isn't necessarily a clarity and a shared language to be able to have that public debate. And it also builds, so if that's a public debate, it builds internal alignment. Because you'd be surprised, or maybe not surprised, that when you work with local governments and you ask them what technology is deployed in this space, rarely is it one person that has that answer. Rarely do they have the whole answer, and you have to continue to dig. And it's not necessarily even clear if a vendor is also collecting some of this data. It's really a process of asking questions and going deeper to build that alignment. And we're finding that DTPR helps with just that process in general. So the next steps is, well, first of all, it is open source. Open source, it's not necessarily software, though it'll become a technical standard. But it is open to be used and deployed for free wherever you'd like. we're building a community of practice, so essentially the beginnings of a governance model, where as an organization, we're a small sort of for-profit company, is not to be the only owner of this, but really have a lot of other organizations involved. We've been talking to vendors of technology who are excited about this, particularly those who, in the device themselves, for example, they build AI that de-identifies the sensor, so it looks like a camera, but no actual video comes out of the sensor, or the camera. They want a third party of trust. They want verification so people understand, okay, it looks like a camera, but actually it isn't recording my face, the data that is being used for planning, etc. There's a need for that kind of thing, and we think that there's a need for then a shared governance across all those different actors. But the challenge, the problem is that, first of all, QR codes aren't great. They're useful in some cases, but they're easily destroyed, hacked with another sticker. And new regulations are almost certainly coming. We imagine that there'll be regulations, if you think about GDPR in your personal digital life, GDPR for a public space, this is particularly European, but we imagine that this will be something that will be coming sooner rather than later. And so in connecting and sort of ending and echoing what Violet was talking about, we imagine a world where if your device had the ability to, you could opt in to what kind of data you wanted collected about yourself when you got into a public space. Or for example, you told your device you wanted notification when you were going to be, you encountered a Bluetooth beacon or a certain kind of camera. Somehow where you are able to understand immediately as you walk into space, if you think about what Violet was talking about in terms of spatial computing, that you have an immediate understanding of the technology around you, what's going on, and an ability to act on it, to say, I'm willing to have this piece of technology connected to use my face or my voice or not, or actually I know that I only want to opt in for certain kinds of companies that have certain kinds of privacy requirements, etc. So that's what we imagine is the future. The first step is building the internal capacity of defining these technologies with a standard like DTPR. But the next steps will get much more interesting in terms of giving us more power over the technology that exists around us. So if you want to learn more, we have our open source project, dtpr.io, and then the company that helpful places.com. Thank you.